So this passenger is pulling the strap of a 15-kilogram suitcase with a force of 70 newtons. The strap makes an angle of 35 degrees above the horizontal. A 37.8 newton friction force opposes the motion, which is horizontal, of the suitcase. Determine the acceleration of the suitcase. So again, we're starting with the free body diagram. We've got gravity, normal force, friction, and we've got this tension that is at an angle. We're interested in the horizontal motion, so we're interested right now in the horizontal forces. The friction force, they told us the magnitude, 37.8 newtons. The tension is 70 newtons, but it's at an angle of 35 degrees. So I'm going to start by finding Tx and Ty. So Tx is 70 cosine of 35 degrees, and that is 57.3 newtons. Ty is 70 sine 35 degrees, and that's 40.2 newtons. So if I think about the net force in x, that equals the mass times acceleration in x, we've got Tx minus the friction equals m times a. We're trying to find the acceleration. I'm going to divide by by m. Ax equals Tx minus f over m. That's 57.3, that's a decimal, 0.3 newtons minus f, which is 37.8. Oh my goodness, I'm having trouble with decimals. Divided by the mass, which is 15 kilograms. And that gives us 1.3 meters per second squared. Now the next problem is very similar. So I am going to see if I'll be able to select part of this. No, you know what I'm going to do. I'm just going to move to the next slide. This problem's the same except for what they're asking us. It says if the wheels are broken and she's dragging the suitcase along the ground, find the coefficient of kinetic friction between the suitcase and the ground. So let's make that free body diagram again. We've got mg, and that is 15 kilograms times 10, 150 newtons. We've got the friction, which is 37.8 newtons. We've got normal force. We've got the tension, and I'm going to draw Tx, which is 57.3 newtons, and Ty, which is 40.2 newtons. Now, I want to know the coefficient of kinetic friction. And I know that the in the vertical direction, we're not accelerating. So let's look at the net force in y. equals mass times acceleration in y. We've got three forces, normal force, Ty, and mg. Normal minus or plus Ty, those are both up, minus mg, that's down, equals the acceleration in the vertical direction is 0. So the normal is equal to mg minus Ty. Notice it's not just equal to gravity because the tension's also pulling it up a little bit, taking some of the weight off. And that equals 92.7 newtons. Now what I'm really trying to find is the coefficient of friction. And I know the friction force equals mu kinetic times n. So mu kinetic is F over n, which is 37.8 newtons divided by 92.7 newtons, and that gives us 0.408. Remember, mu is a unitless number.